a particle P starts from rest at O. So just that part of that sentence is telling me that x equals 0 and v equals 0, that's rest, when t equals 0. Then it moves with a variable acceleration a meters per second squared, where in the first 5 seconds a is equal to t over 5, and then after that a is t over 5 plus 10 over t squared. In part A we want to show the speed of p is 2.5 meters per second when t is 5, and 11 meters per second when t is 10. So let's look at part A. Well, in this first 5 seconds, v is going to be the integral of t over 5 dt. So that's going to be t squared over 10 plus a constant. We know v equals 0 when t equals 0. And if we substitute into there, that shows c equals 0. But always be a bit careful with that. We can get functions here that when you substitute t into, they're not 0. And we may not always be given the condition when t is 0. But here that's fairly clear. So let's just go straight to it. So we know that v is t squared over 10. And we're after v of 5. We want when t is 5. So that's going to be 25 over 10, which is 2.5 meters per second. And that's what we're after, 2.5. Now we need to go ahead and look where t is 10. So, in this region, v is going to be the integral of t over 5 plus 10t to the negative 2. So that's going to be t squared over 10. Then we want to add 10t to the negative 1 over negative 1 plus a constant. So that's t squared over 10. Take away 10 over t plus a constant. Now this motion starts when t is 5. And we know that v equals 5 when t equals 5. Sorry, v is not equal to 5, just going over here, v is 2.5. Substitute that in. We've got 2.5 equals 25 over 10, take away 2 plus c. So 2.5 equals 2.5, take away 2, add c. If we look at that, c must be equal to 2. So here we have that v is t squared over 10 minus 10 over t plus 2. And we're after v of 10. So that's going to be 100 over 10, take away 10 over 10, add 2, which is 10, take away 1, add 2, is 11 meters per second, as required. Now in part B we want to show the displacement of p from O when t is 10 is this distance here. Now I think we've got to go through a similar sort of process with x. So let's look at the first 5 seconds. That's going to be the integral of t squared over 10 dt. So that's going to be t cubed over 30 plus c. But we know that x is 0 when t is 0, so that means c is 0. So x is 0 when t equals 0 means c equals 0. And so x would be t cubed over 30. So what does that mean about x of 5? So that's going to be 125 over 30. Let's just use the calculator to cancel that down. 125 over 30 is 25 over 6. So, now we want to look at x beyond 5 seconds. So that's going to be the integral of t squared over 10, take away 10 over t plus 2. So x is going to be t cubed over 30, take away 10 ln t, and t can't be negative, it starts at 0, plus 2t plus a constant. Now we know that when t is 5, x is equal to 25 over 6. So 25 over 6 is equal to, well, we know that 5 cubed over 30 is what gave us 25 over 6. Take away 10 ln 5, add 10 plus c. So these cancel out, and we'll have 0 over there. So c is going to be 10 ln 5, take away 10. And that gives me that x is t cubed over 30 minus 10 ln t plus 2t plus 10 ln 5 minus 10. Now before I go on to the last part, this says 43.5, but looking at the answer of the question that I copied, it should actually be 43 1/3, not 43.5 there. So I've corrected that in the notes. So we want x of 10. That's going to be 1000 over 30. Take away 10 ln 10. Add 20. Add 10 ln 5. Take away 10. Now as far as the numbers are concerned, we've got the 1000 over 30, add 20, take 10, which is the same as doing this, and that is 43 1/3. So 43 1/3. Then if we do minus 10, in here we'll have ln 10, take away ln 5, and using a log law, that's 10 ln 10 divided by 5, so that's 43 1/3, take away 10 ln 2, as required just here.